solve for the unknown in this given logarithmic equation. So we are going to decode the value of x, and here we are not going to use any calculators. There are two possible methods that you could use here. I'm going to present to you the two methods, and it's up to you to which you're going to follow later. But first, let us try to be reminded of that whenever we have a logarithmic equation, we can transform it into an equivalent exponential equation. If we have, just for a general background, if you have a logarithm of a to the base b is equal to any variable x, we can transform it to an equivalent exponential equation in this manner. You're going to use the same base. The equivalent would become your exponent x and would be equal to your coefficient of a. We are going to use this later, probably as part of our discussion. It may help us decide the result later. Again, I'm going to present the two methods. The first method I'm going to share is, of course, one of the, among the two methods I'm going to share, this is actually easier to be understood. Okay, if you have already the foundations for logarithmic equations or logarithms. Of course, we have the coefficient 2, and it is also 2 here. To make it easier, we can divide both sides by 2, right? By dividing both sides by 2, you will have that. You will have this as well. So you will have a form here. A logarithm of x to the base 4 is equal to 1. Okay? So it looks easier now because you were able to divide both sides by 2 because we have a coefficient 2 here. And then we are going to apply here the transformation. You will have 4 to the power of 1 is equal to x. In short, the value of x in our given equation, the value of unknown is equal to 4. And this should be the answer here as well. Now, this is a good method, and you could use this as well. And if you can use this, then it's good that you have this foundation already. But I'm going to present to you another method. But of course, again, this first method is easier because you were able to divide here. But what if, say for example, what if your coefficient here is not the same as here, or a different prime number? Of course, it's still okay even if you will get a fraction here, but some of us have difficulties as well in dealing with fractional exponents. So again, this is another method that you could also use. This method, again, I'm going to write here the given. 2 logarithm of x to the base 4 is equal to 2. What you could do here is apply the property or one theorem with regards to logarithms or logarithmic functions or equations rather. This coefficient here can be placed as an exponent of this variable here, or the value, whatever the value you could place here. So this could mean that this is equivalent to, let's use the arrowhead, logarithm of x squared to the x squared, sorry, I was thinking of x squared. X squared to the base 4 is equal to 2. Don't worry about the square because we are going to move to the transformation here. So you have 4 squared is equal to x squared, just like this. And of course, you can take the square root of both sides right here, right? When you take the square root of a number, take note that you will allow positive and negative results. So by symmetric property, x is equal to positive and negative 4, as the square root will cancel out this exponent here. But be guided that for the value of this form here, or a variable, we are only going to accept the positive result. So here and previously, you have the same results for your x, and these two methods are acceptable and are correct. So we have decoded now the value of x, which can satisfy this equation. And that's mission accomplished.